Hey guys, and welcome back. My name is Caproni, and this is your ACT prep. So what I've done is ask students over and over and over again, what is the topic on the ACT that you are most afraid of? And almost always the answer is trigonometry. Not because trigonometry is super difficult, but just because students don't feel like they've been adequately prepared for it. So I'm going to go ahead and do 3 quick videos over the extreme basics of trigonometry in hopes that it's going to help you for your ACT. So stick with me and let's get started on the first video for trigonometry. So trigonometry is actually the study of triangles when you're looking at the relationship between their side lengths and the angles involved in them. Now, for the most part, we deal with right triangles when doing these studies because there's a lot of really easy ratios and formulas to use. But really, trigonometry will work for any type of triangle. It just changes the game a bit. Now, today we're going to be looking at the 3 most common trigonometry ratios, which is your sine, cosine, and tangent ratios. And we're going to talk about how to label a triangle and get to those ratios from there. So let's go ahead and start off by looking at a right triangle. So as I said, trigonometry is the relationship between the side lengths and the angles in a triangle. So when we're labeling a triangle, we need to make sure we're talking about both. And in general, a right triangle always has the same 90-degree angle that's currently marked on the triangle right here. Now, the other major angle we're talking about is usually called theta. Now, theta is a Greek letter where it's essentially just an O or a 0 with a line through the middle. But theta is the most common labeling of an angle for a triangle. Don't ask me why. Maybe someone had one too many toga parties in college. But regardless, theta is what they use. So this symbol right here is marking of theta. Now remember, we're all worried about the relationship between our angles and the side lengths. So usually we only label one angle at the start, and then we will base the labeling of the rest of the triangle off of that one angle. So looking at our 3 sides here, we have the one that is directly across from the angle that we're looking at, and we call that the opposite side of the triangle. The second one we have is the adjacent side of the triangle. The adjacent one is the one that is touching the angle that we are currently studying, or the one that we're using for the problem that is at hand. Now, the last one is your hypotenuse. And your hypotenuse is always the side that is across from your right angle. But Mr. Caproni, what if they called the top of my triangle theta instead? That's completely fine. It doesn't really change much. Remember, the hypotenuse is always the one across from the right angle, so it just comes down to relabeling the other two. Now the one at the bottom is going to be across from our theta, and the one touching it is going to be on the left-hand side, so we'll call that the adjacent side. Now, once we have these 3 labels, we can start looking at our first trig ratio. Now, a trig ratio is just where we look at how a specific angle relates to the ratio formed by 2 of the side lengths. In this case, we're going to look at sine. And the sine of theta is always equal to the opposite over the hypotenuse. In other words, we are going to take the side length of the opposite side of the triangle and divide it by the side length of the hypotenuse. So why would we need a ratio like this? Well, here's the deal. Once we have the ratio set up, our calculator can do the rest of the work for us. So if I know the angle and one of the side lengths, because this is a right triangle, I know that as we keep making the triangle bigger and bigger and bigger, that the ratio always needs to stay the same. So we're able to plug in pieces of this to be able to solve for whatever we might be missing. So let's say we have the angle, but only one of the side lengths involved for sine. Well, we can find the other side length through the use of a calculator and our new knowledge of this sine ratio. Likewise, if we're missing the angle itself, but we have both the opposite side length and the hypotenuse side length, we are able to then go back and find the angle using a calculator again with what we call our inverse trig function. Here's the deal. We don't always have the opposite and hypotenuse as our side lengths. Sometimes we have the adjacent and the hypotenuse instead. For that reason, we're moving on to our second major trig function, which is known as cosine. Cosine works the same way as sine, where we're doing a relationship between that theta angle and the side lengths next to it. In this case, though, we're not going to do the opposite over hypotenuse. We do the adjacent over hypotenuse instead. So at the end of the day, it works the same as sine in the calculator for finding those missing values, but we're working with the adjacent, hypotenuse, and the angle instead. Now, our last type of trig function is when we don't have the hypotenuse, and instead we might have the opposite and adjacent side lengths. In that case, we use the tangent function. And the tangent function works the same as the last two, but in this case, we are dealing with the opposite side length divided by the adjacent side length. No matter which of the three you have, you will treat this problem the same way. It really is just coming down to knowing how to properly label your triangle and label the correct trig function that goes with the problem you're trying to solve. Because the number one thing that students are needing to do with trigonometry is just know how to properly label things and then move them into the trig ratios, they came up with a common phrase to help remember which side lengths go with which trig functions. They refer to that as SohCahToa. So if you've ever heard someone say SohCahToa, they're just trying to help you remember what are the ratios that go with each of the major three trig functions. So as you notice, this SohCahToa starts with so, which is sine, which is opposite over hypotenuse. Then you have the ka, which is your cosine with adjacent over hypotenuse, and then the toa with the tangent function being opposite over adjacent. So as long as you get that memorized and down to a T, you should be good with setting up your problems to solve. Let's go ahead and practice using a labeling of this triangle to fill out our trig ratios. So if you look here, we're starting off with the sine of theta. Now the number opposite of the theta is 3, and the hypotenuse in this case is 5. So since sine is the opposite over hypotenuse, the sine of theta would just be 3 over 5. Then if I move on to doing the cosine, we would be talking about the adjacent over the hypotenuse. So we use that 4 instead of the 3. So if I wanted to set this up for calculator use, it would be the cosine of theta would be equal to 4 divided by 5. And lastly, the tangent is when we're dealing with the opposite over the adjacent, which gives us 3 over 4 in this case. There you have it. That's the basic labeling of a trig function setup. Now, you need to know the triangle labels of the opposite, adjacent, and hypotenuse, and you need to know which trig functions go with which side lengths. Now, in the next video, I'm going to talk about the other 3 trig functions and go through that same labeling process with them. Then after that, the third video for this series is actually going to be looking at common graphs of the 3 functions and where those graphs come from. So as usual, guys, thanks for joining me today. I hope you found something useful. If you did, go ahead and hit the like button below. And if you want to keep getting videos like this week after week, then go ahead and hit that subscribe button as well. Again, my name is MrCaproni, and this has been your ACT Prep.